CMM Quarterly covers the topic of simple distance. First, we must discuss point-reducible features. These are features that can be reduced to a point. A circle, sphere, and torus have a center point. You can also construct points such in the intersection, or a cylinder or a cone to a plane. These are all point-reducible features that can be used. You will find the simple distance command under the size distance menu. There are several selections within the simple distance dialog box. We will cover each one in this video. Checking the X, Y, and R boxes gives you the distance along the X-axis, the distance along the Y-axis, and the radial distance. Checking the X, Y, and 3D boxes gives you the distance along the X-axis, the distance along the Y-axis, and the 3D distance. Checking the X, Y, R, and A boxes gives you the distance along the X-axis, the distance along the Y-axis, the radial distance, and the angular distance. (2D) polar distance is the distance between 2 point-reducible features normal to a datum. This is similar to simple distance, R value. (3D) polar distance is the straight line distance between features at different heights. 3D polar is similar to the 3D in simple distance without the alignment constraints.
We are going to look at Cartesian distance. We want to measure the distance between these two tooling balls. So we need to measure these features. Add the Cartesian distance. Now open up the characteristic. Let's add the two spheres. For the primary datum, choose plane 1. This will create the view parallel to this plane's space axes. The secondary alignment will be plane 3. The secondary alignment defines the orientation of the part. So to clarify what's happening is when we chose plane 1 as the primary datum, we are now viewing down onto plane 1. When we choose plane 3 as the secondary alignment, this sets the orientation or the squareness of this distance calculation. Now let's get the other Cartesian distance. Open Cartesian distance. Select both spheres. For the primary datum, again we're going to use plane 1. For the secondary datum, we are going to use plane 2 and keep the Cartesian distance parallel to plane 2. We're going to show an alternative method next, but let's keep this parallel too. By using plane 2 and keeping it parallel, we get the 2-inch dimension. Here's the optional method. Let's open the distance. Let's change plane 2 back to plane 3 and choose perpendicular 2, and you can see we picked up the 2-inch measurement. In Calypso, whenever just two features are recalled, the first feature defines the origin and the second feature defines the orientation. Now let's look at that concept. First, let's set the origin on the first feature, sphere number 2. The second feature will set the orientation, and that will be plane 3. Using this method, we get the distance normal to plane 3.